All right, so we have James Kubli hosting this week, and he's going to be talking about the CFD to simulation mechanical interoperability. James has been with us for about 3 years now, supporting simulation mechanical and some of our other simulation products. So at this point, I'll turn it over to James.
Good morning, everybody. Thank you for joining us in this webinar presentation. We're going to discuss, as Andrew mentioned, how to transfer results from CFD to mechanical for purposes of analysis. Before we get started, though, a quick reminder of previous presentations we've done on weld analysis, intro to MES or mechanical event simulation, what's new in simulation mechanical, our new Nastran InCAD product for Inventor, and tips and tricks on meshing. One thing I do want to point out, though, is that we do have a new hot fix just recently released for Simulation 2015 R1. I recommend downloading it and keeping your program up to date. So, on to interoperability between CFD and mechanical. Why do you want to use CFD? It's a very powerful program and very easy to use for fluid and thermal analysis. Now, even though mechanical does have thermal analysis capabilities, you'll find that our CFD program is much more capable because of the fact that you can have coupled analysis. You can have both fluid flow and thermal. And I will actually demonstrate a model where temperatures are, where I use a fluid flow analysis to create the situation, the cooling and heating situation in which stress is present in the model. But we can not only map thermal, but we can also map fluid pressures, or the pressure results from a fluid flow. And that's actually going to be in my first example. So we're then going to go on, I'm going to give a presentation here on, or give an example of how to select the results from a CFD analysis for use in your mechanical analysis. The process is actually very simple, and it'll actually be probably the shortest part of the example. We'll go on to look at the results, and then afterwards, after I'm done with the two examples, I'll discuss some of the limitations and where we don't have functionality at just yet. So we'll go on to the first example here. Because Sunday is Super Bowl, I've gone with a field goal post for my first analysis type. It's just a simple tubular structure. And so we're just going to, I'm assuming most people are from a mechanical background or simulation mechanical background, so we're going to go through all the steps needed for these two models, or for the two analysis types.
So while James is getting this set up, I just want to mention that if you have any questions during the presentation, there's the you can type those into the chat window, or use the questions option, and there's members of the various simulation products here to help answer some of those questions.
Thank you, Andrew. So first thing we're going to do is we're going to create our external air volume here. This is going to be just kind of really small to just get us the analysis going, so we don't spend too much time watching the analysis run. All right, so now we've got our external air volume. Select that, edit, we'll assign it as air. And we've got our post here. We have some extra volumes. What I did is I built little caps on here because these are hollow tubes. I put little caps on here so that way it would create a separate volume inside the tube, and I won't actually have to deal with, I could separate them and not actually mesh them. Just set all materials, or every body requires a material whether it's used or not. So I like to use ABS plastic or the ABS molded because it's a nice bright color, and I hardly ever use that material. So I know that that's not something I'm using in my model. Boundary conditions, very simple. We'll have an inlet. Let's go with 30 miles per hour. And then we'll have an outlet. Zero pressure outlet. Very similar to the way simulation mechanical or multi-physics fluid part would work. We'll go to mesh sizing. Just set an auto size. I'm going to tweak it just a little bit. Add a little bit of surface refinement. The curvature of the pipe and the thinness of the wall will make meshing a little difficult initially. And we're going to go with all the defaults. We'll run it for 100 iterations here. And shouldn't take too long to run. No, I haven't covered much yet, but does anybody have any questions at this point?
Not seeing any questions come in yet, so if you do have any, certainly don't hesitate to type those into the chat window or the question window. And like I said, there's specialists here to help answer any questions that may pop up.
Sure, there's something we can do while this is running. I can start setting up the mechanical model. No, we're going to go with linear static. Those are the extra parts I used in CFD, the little caps, just suppressing them. Anyways, options. Let's see. Last time.
So we did just have a question come in here, James. Gonzalo would like to know, is there any setting for surface boundaries on the poles?
Surface boundaries on the poles. Is this in relation to CFD or mechanical?
See if we can get a clarification there. Gonzalo says in relation to CFD.
Okay. No, there's no need for any boundary conditions on the poles themselves. There's no constraints, and everything's rigid in here. Just the volume here is considered fluid. So we only have our flow in and our flow out. The program will recognize the solid parts as solids and creates the boundary condition on them. The mesher, using automatic mesh sizing, automatically creates the boundary layer on all solid parts and along any external fluid volumes. Does that answer the question there?
May I add something?
That looks to be the case, Jim.
Basically, and yeah. So basically, it's a non-slip boundary condition anywhere at the interface between fluid and solid. By default, it's a non-slip boundary condition, so the fluid velocity at the surfaces of the goalpost would be 0.
All right, so thank you, Marlon. So mechanical here, I've got the model fully meshed, solid mesh. I got my constraint, it's fixed on the ground, and we are still, CFD is still running here. Apologize, I thought this would have been done a little quicker. Oh, wait, no. Well, while that's going on, I have another presentation here that we can also look at.
So Adrian has another good question here. Mm-hmm. Do the mesh size in CFD and mechanical have to be correlated?
No. They do not have to have matching meshes at all. If you look closely in CFD here, it's all tetrahedral mesh, but in mechanical, the default mesh are brick elements, or well, not brick. They are what is it? The square elements. Sorry, I'm blanking on the term for the 8-sided elements.
Quadrilateral elements.
Yes, thank you. Though due to the curvature here, it looks like we do have a lot of tetrahedral elements in it too. But it's not required to have the same element type, as long as it's just solid elements, brick or tetrahedral. Either one will work in mechanical, and CFD basically just offers the tetrahedral when solid meshing. There we go. Our analysis did complete successfully here. We'll take a quick look at the results as they're still updating.
Wilmer has a question here as well.
Sure.
Can the surface pressure from CFD be transported to shell elements in MES? And I believe the answer is no.
Correct. Unfortunately not. It only works for solid elements currently and 2D analysis. Axisymmetric, for example, is supported both in mechanical and CFD. Let's go. Shaded view. All right, still waiting for the results to display. Oh wait, no. Velocity, magnitude, global. Well, I'm not sure what is the holdup just yet here, but here's our other analysis where we do thermal, and this is one of the major advantages of CFD is I've got a fluid flow through a valve. Let's hide this so you can see it better. So we've got fluid flow through a valve. The temperature of the fluid is much hotter than the temperature of our valve here, and there are thermal constraints or temperature boundary conditions on parts of the valve here that keep it cooler than the fluid flowing in. So we can see the effects here. If we go back to There we go. This was the steady state, and then I transitioned into a transient, or I then switched over to a transient analysis to see the temperature change. I apologize here. I'm not quite sure why the results didn't work, or why I'm not getting what I expected. But worst case scenario here, I do have a successful analysis. And I will show you how that looks. So on the pole itself, we can see the pressure. And then on the slice plane here, we can see the airflow, the velocity change as it passes, or as it hits the post. So we go on into mechanical here. We've got our model. Well, there's a couple ways to access it. We can go to here, CFD results, drop down, apply thermal or fluid. We can also go into the analysis parameter. All it does is take you into the analysis parameter into the proper tab here. So we're going to go to fluid reactions, simulation CFD file. We'll go to the functioning one. We'll browse to the CFDST file, open it up, and then what we're going to see here is a slight little problem here that you can run into if you forget something. You'll see that these drop-down options are blank. I can't select anything. The reason for that is that the model is still open in CFD. We actually have to close the model down in order for this to work. So we'll go back into it again. Aha, see now the drop-down work. We're looking at design 1, scenario 1. You'll see different options depending on how many scenarios you have on it. We only have one currently, so it automatically selects it for us. And that is pretty much all you need to do to assign pressures to CFD, or to a mechanical analysis. And we can run the model now. Yeah, as I mentioned before, the assigning pressures and thermal is very simple. In the 2015 release, we've dramatically improved the process from before. All you have to do is browse to your CFD model file, select which scenario you want to use, design and scenario, and run the analysis. And there we are. Our 30-mile-per-hour steady-state wind creates a 0.33-inch displacement magnitude at the end of the field goal post. Looks pretty good. Our stresses, pretty low. I think it's a successful design. So let's move on to the thermal. As we can see here, we have, it's again going to be just as simple, but this thermal here analysis really plays onto the strength that CFD can offer, and that's the coupled fluid thermal flow. So we'll go into mechanical. This model's already been set up. It has been solid mesh and everything to make it just a little bit quicker. I already have the fluid flow results here. Because of the length of the analysis it takes, the fluid analysis is can be relatively long, and then throw in the thermal. So again, we're doing a static stress with linear materials. You want to turn on thermal here. Go to here. We're going to browse to the file. Again, I made that mistake. I have CFD still open. We want thermal. Select our model again. You'll see I have a few different options here with this model. Design 1, Scenario 1 is a steady state, and Design 1 transient here is a transient analysis. We get a different option this time. We now have which step we want to use. For the steady state here, I had multiple save outputs set, so that's why I have multiple options here. Same thing with the transient. We can pick which time step we want to use. Okay, and with that, the model has the material properties, and everything's mesh, material properties assigned, and constraints. And if we run the analysis, which I'm not going to run because of the time it can take, just to make things a little quicker, we will get displacement and stress. That's all it is. There's no other loads. It's just the thermal applied load. So that's how easy it is now to integrate CFD with mechanical. We can also do fluid reactions here, thermal. The setup is exactly the same for nonlinear. So that brings us to any questions. Anybody have any questions about the workflow or how you translate fluid and thermal results to mechanical?
So Casey had a good question. We answered it in the chat thing, but I figured I'd share it as well. He's wondering how we loaded in the model to SimMechanical and how we brought it into Simulation CFD. He was wondering if we're maintaining surface identification or anything like that. And I think we have the interpolation add-on kind of to Simulation Mechanical that's going to interpolate between the mesh points in CFD to what's generated for a mesh in SimMechanical, so that you don't have to maintain kind of surface identification numbering and things like that.
Correct. In fact, the part numbers, if you were to look at the log, you can see that the part numbers, or not even necessarily the log, you can see that the part numbers from mechanical to CFD don't even correlate it to each other at all. So there's no worries about maintaining any sort of surface. As long as you have the same model and the same objects in there, well, not even necessarily the same objects. You can see that in the CFD model, for the first analysis I had, there is a fluid. I created an external fluid body that was not necessary in the mechanical. And then some parts were suppressed from suppressed in both of them, but you can suppress parts that are not necessary, that are used in CFD that are not necessary in mechanical.
So Adrian has a question here. Can I import the cyclic thermal stresses, a transient analysis, from CFD into mechanical in order to use the thermal stresses in fatigue analysis?
Well, let's take a quick look here. I don't think there's actually going to be an issue. Well, let's see, analysis.
Can I say something here? It's really two issues here, because one question would be, can I perform a transient heat transfer analysis in CFD and import that profile to maybe use in an MES analysis? Because the fatigue is different. If you want to run the fatigue analysis wizard, as you know, it is in Simulation Mechanical, that fatigue is only going to take one snapshot of the stress state. right? It's not, and it's going to cycle based on a load curve that you define inside of fatigue. So again, the input to fatigue would just be one snapshot, and you can give it a certain profile inside of fatigue. It's not a time-dependent thing inside of the fatigue calculations.
Correct.
That
Yeah, you would
only here.
correct. You'd only be able to select one of the stress outputs. So you'd only have one result, and it would be, and you would then define through here how that would behave cyclically. So you wouldn't be able to take the time stress or the stresses as they change from time and use that as your cyclic load. You would have to define it manually this way.
Correct.
At that point.
So the other question is, if you were to do a transient heat transfer analysis in SimCFD, can you bring that entire profile into what would have to be an MES analysis in SimMech?
Correct, you can.
Okay, let's take a look at that.
All right, we're going to set up a mechanical one here. So we're going to want temperature dependent. We're going to want a stress-free reference temperature. And we'll have to define our materials. We don't have any default materials for temperature dependent for MES. So we'll have to manually define it. I don't know what aluminum is off the top of my head, so I'm going to go with steel here.
Something like 10 e to the 6. Something like 9 e to the 6, I believe, is aluminum.
9?
Yeah. That's good.
Either way.
Yeah, no, that's not going to make a difference for this example.
Yeah, not a huge difference. In fact, I'm not even going to put any variance in material properties for the temperature. I'm just going to stick with the exact same values.
But you will need 2 data points. One is not going to be enough, even if they're the same numbers.
Correct. You'll want one below and one above expected temperatures. Let's see. So I'm just pasting all the...
Well, you probably wanted all attributes since this was set as temperature dependent.
Yeah, thank you. I did not get... let's just go all.
Yeah.
Yeah, I forgot. Modify the element definition, so...
Yeah, just, yep.
There we go. Loads and constraints, surface.
Another good good tip you're showing there, James, where you can actually paste attributes from other parts and mass select parts to paste those to. I know a lot of customers aren't aware of that functionality, and it can really speed up some workflows.
Oh, yes, I love it. It's very handy.
So attributes would be element type, element definition, material, and the color.
Mm-hmm. So we go into the analysis parameter. There are thermal. There's fluid too, but thermal. I do have a transient setup for this. There is a low curve defined. I set the low curve multiplier from 1 at time step 0 to 1, and the finish to 1. If I was to set this to 0, it would take the temperature, whatever temperature it was, 100 degrees, 20 degrees, it would multiply it by 0, and I ended up starting off at 0 degrees. And wouldn't actually be correct, because with my CFD model, I actually ran a steady state to see what it would be like, and then I time varied the temperature of the fluid flowing into it to see what would happen with the change in temperature of the part itself. So I have my analysis in my transient analysis in CFD was 40-second analysis. I've added that duration here. I've added a number of time steps to run that for, and we are set. That's all you need to do to define how to run it. I can run the analysis, but I don't know if we'll get to results in time. But that's basically all you need to do to set up your analysis. Would you like to see the CFD side, or is it just more the mechanical side that you wanted to see how to set it up?
Looks like Adrian was just interested in the mechanical side of setting that up.
Okay.
I'll give you answer this question here.
All right. Anybody else have any questions? I know it's a very easy way. It's very easy now to transfer results from one to the other. I guess if there's no other questions, there is one other thing I wanted to talk about. I think we actually covered it in the question, was the limitations. Currently, it supports 2D analysis and solid elements, or solid models. We also cannot couple deformation, changes in deformation to changes in fluid flow. For example, if you were to, let's say, rubber diaphragm, for example, we could not model how the change in fluid flow would affect the diaphragm, and then the deformation of the diaphragm affect the flow itself. So if we were varying the flow and there was a diaphragm that was being affected, changing the diameter of a tube or something along those lines, or even used for pressure flow, we cannot model, we cannot couple the deformation of that to the fluid flow. So we can only work with basically inflexible objects in CFD and then translate those results into mechanical. We can't then take the deformation of mechanical and then translate that into CFD to see how the flow changes.
One last thing I want to add is that you can, set up the models, since you do set them up independently up to the point where you actually import the temperature or the static pressure from CFD. You can, while the CFD analysis is running, you can bring up the model in some mechanical and start, matching it and setting it up, waiting for the results to be available from CFD, and then import those.
Correct.
So it looks like the stream of questions has kind of died down. Actually, it looks like we've got another one here. Is it possible to translate force results from CFD free surface example to mechanical? So I think the forces would come in, translate as pressures, if I'm not mistaken.
Yeah, you could, for example, let's say if you modeled a tsunami hitting a building, there's a pretty cool video out there of CFD being able to solve something like that. You could take the pressure from that transient analysis and bring it into simulation mechanical and model the deflection of said building against against the fluid flow. It would just be a pressure, just like we experienced, just like the pole saw or the field goal post saw.
So John Wild's in here as well, and he mentioned that he'll be showing this example during one of his upcoming presentations on free surfaces in Simulation CFD. So that's something to look forward to.
I highly recommend it. It's a very cool looking video.
So John will be doing a presentation on February 11th, and that's when I'll be showing off some of this functionality. It does look like we have another question here about unit limitations or warnings. I believe one of the existing limitations is the unit systems need to be the same between simulation CFD and mechanical for the results to map properly.
Yes, that is correct. But in mechanical, you can change the view of your units. So we can always look at things in millimeter or even custom units. But we always have, in mechanical, we'll always be having the model units. So as long as this model units matches the unit system in CFD, there won't be a translation issue. But yeah, in mechanical, we can always change the unit system, at least what's being displayed, and when we change that, we can change the units that are applied in loads change with that with the matching display system. See, now it's newtons. But if you're starting off with the same model, working in Inventor, for example, here, this is the unit system that's being imported into CFD and then also being pushed into mechanical.
One last question here from Milton. He's wondering if we're going to be emailing the video out. So you can actually find all of our presentations on the Autodesk Sim 360 YouTube channel. It may take a day or two for some of these presentations to get posted there, but we're usually pretty good about getting everything up there. So all of our previous webinars are posted on that channel, and that's just Autodesk Sim 360. So if you go into Google and type Autodesk Sim 360 YouTube, it should be one of the first links there, and there should be a list of the videos available to view. So it seems like we've run out of questions here to answer, so I'll give everyone just one more minute here to ask anything that they may be holding on to. It doesn't necessarily have to be about the presentation today. If you have a question in general about simulation mechanical or simulation CFD, we'll certainly be glad to answer that as well.
Thank you, Andrew.